Hello, guys. So, this is the seventh class of economic geology. We'll start with um, actually, we were continuing different deposits and their occurrence, their orogenesis, their orogenesis and mineralogy, and then Indian examples and foreign examples. So, we'll continue that and then we'll start with geology of uranium. So, mineralogy of uranium deposits in India. Uranium is primarily found in its oxidized form, particularly as uraninite. Uraninite UO2 is the primary ore mineral of uranium, uranium oxide, which is the most common ore mineral. Okay, uraninite. Other uranium minerals found in deposits are just pitch blende is also sometimes common, UO2, along with other oxide minerals. We have coffinite, USiO4, autunite. It's a very big formula. You don't have to memorize it. Torpedoite, again big formula. Curite. Okay, the uranium content in these minerals typically ranges from 60 to 80% for uraninite, while others contain much less uranium. So mostly it is confound to uraninite. Altered uranium ores. Uranium is often found in secondary minerals like bannerite, thiomunite, and uranophane due to alteration of primary ore minerals under oxidation conditions. Now, orogenesis of uranium. So, earliest uranium in early stage of Earth formation, as core and mantle solidified, uranium being incompatible ejected to fluid crust, and solidification of this crust gave uranium. So, uranium is found in earliest of Archean rocks. Leaching of this causes uranium to concentrate at one place, which is uranium deposits. So, mostly happens due to leaching. Leaching means concentration of a particular ore minerals, okay, due to absorption and desorption. Okay, so uranium is also actually a incompatible element, so it is mostly confined to fluids, and solidification in this crust gave uranium. And source of uranium originates from Archean granitic sources, generally through weathering. Okay, so by weathering they are they originate. The solubilization of uranium in oxidizing condition, this uranium gets dissolved from source to form oxyanionic complexes. Now, fluid formation, also hot uranium enriched hydrothermal fluids are generated from cooling magma. These uranium rich fluids migrate through fractures and permeable rock formations. Okay, so they migrate in permeable rock formations, then they precipitate there. Uranium precipitation out as insoluble minerals, example uraninite, when fluids encounter reducing conditions or cooler temperature. Remember, precipitation happens in a reducing condition where there is lack of oxygen and where uraninite precipitates as an insoluble mineral. So it is not soluble with water. So insoluble mineral, they get I would say not soluble is not a term here because everything water is a universal solvent, so everything is soluble in water. But yes, the chances of solubility of mineral uraninite is very low. Okay, so when fluids encounter reducing conditions or cooler temperatures, they get precipitated as uraninite. Host rock and structure. So, deposits are typically found in sedimentary rocks or within fractures in igneous rocks, Archean age granite, often concentrated along structural features like faults. Okay, so in faults, they can be there. So, maybe so this is a fault surface. So, you can find uraninites in these areas in fractures. Okay. Okay, so uranite deposition can be present here. So they will occur fractures here, okay, along the fault surface. there will be fractures. So on these fractures, since these are actually have high permeability and high porosity, so this results in precipitation of these uranium deposits, but also reducing condition is important. Reducing condition, fine. So in India, uranium deposits are primarily found in Proterozoic, that is 75%, and Phanerozoic geological formations. Okay, so Proterozoic and Phanerozoic are the important uh, locations, important time zones where rocks were deposited, and they have a chance of, it's like we have a chance of getting uranium in those deposits. Uranium deposits in India mainly occur in Precambrian and are typically associated with metamorphic, granitoid, and volcanic rocks. Metamorphic, granitoid, and volcanic rocks mostly, no sedimentary deposits. But there occur uranium deposits, sedimentary deposits, maybe in different places. But in India, we are mostly concerned to metamorphic, granite type of rocks and volcanic rocks. So main modes of uranium are minerals, common nodes like uraninite, coffinite, and autunite. We get rocks found in granite, shale, sandstone, and limestone. See here, shale, sandstone, limestones. We also get these mineral deposits, these uranium deposits. So soil and sediment present in trace amounts, but often near mineral deposits. So often, say for example, say we have a, say, a faulted area here, maybe some faults here, and we have deposits like this, and this is our soil cover. Okay, so some may get leached, okay, leached in the soil, and some trace amounts of uranium can be present in the soil also. Okay, so this is the soil, and this is the host rock. Okay, so soil and sediments present in trace amounts. Okay, seawater dissolved in very low concentrations. We also get it in seawater, because you will see that in the bottom of the sea, in the deep marine environment, we will see that there is a reducing condition. Okay, we will see often that there are reducing condition, that is lack of oxygen in the deep marine environment. So in deep marine environment is very favorable for uranium deposits. So if there are any kind of, say, horse and graben structure beneath the ocean bottom or in the deep marine setting, or there are any permeable zones are there, any fault zones are there. So there can be chances of uranium deposits, because it is the ideal condition for those deposits. So when they, that happens, usually happens during the Proterozoic or the Archean eras. Now if they are exposed to the Earth's surface, then we can get uranium deposits at those places. So uranium occurs in following modes. So primary deposits, orogenic or endogenous, found when within Earth's crust through precipitation from hydrothermal fluids or magmatic differentiation, found in granitoid rocks, pegmatites, and metamorphosed sediments. So secondary deposits, we have exogenic or sedimentary, concentrated through weathering and leaching by surface water deposited in sedimentary basins. Okay, sedimentary basins we get mostly in sedimentary rocks, and primary deposits we get in granitoids, pegmatites, and metamorphosed sediments. Then we have vein type deposits, so very common, found in veins found from hydrothermal process, such as pitch blende veins in India along fractures and sedimentary and metamorphic rocks. So you can see these are the ore zones greater than 0.05% of U3O8. Then we have sandstones, unconformities, granite, melodic gneiss. So not an important diagram to draw in your exam, but yeah, just to visualize things. Okay, so types of uranium deposits in India. Okay, very important. So vein type deposits, Singhbhum shear zones and Jharkhand. Okay, so we have vein type deposit. The first one, vein type deposits, very common. Singhbum shear zone, because it's a shear zone, we will have a lot of fractures, lot of permeable areas for those deposits. It is in Jharkhand. So in Archean granite, metasediments of Singhbum group, it's in granite. We have pitch blende, is the ore mineral associated with chalcopyrite and pyrite. Controls strongly localized along shear zones. Okay, northwest trending. Okay, northwest trending shear zones we have. Alterations are chloridization, silicification, and hematization. Hematization is formation of hematite. Silicification is formation of like renewed formation or alteration to any silicic mineral. Chloridization is formation of chloride. Then genesis, uranium bearing hydrothermal fluids migrate along reactivated shear zones. Okay, this is the Singhbum shear zone, and precipitating uranium minerals like pitchblende due to cooling, pressure drop, and chemical interaction with host rock. So we have uranium bearing Singhbum shear zone. If you always name it like this, uranium bearing Singhbum shear zone, uranium bearing Singhbum shear zone, so that if you ever hear the term Singhbum shear zone, will automatically link it with uranium. Okay, so uranium bearing Singhbum shear zone. Unconfirmed related deposits, that is Lambapur, Peddagattu, Telangana, Kadapa Basin in Andhra Pradesh. Okay, so unconfirmed related, this is deposit. So always remember, so uraniums can be present as unconfirmed deposits. Okay, above the unconfirmity or below the unconfirmity, or it can be present as vein deposits. So in India, mostly we get these two type of deposits. So host rock is Sri Salem sandstone over Archean basement. So Archean basement is there, and then we have Sri Salem sandstones. Okay. Say for example, this unconformity is there. So this is the Archean basement, and here we will get along the unconformity we will get uranium deposits. So uranium minerals are pitch blende again, uraninite and coffinite. Controls near the unconformity surface between sandstone and granite. So since there is a gap between the two deposits along the unconformity, you will always find some amount of permeable zones. So at those zones, if there is reducing condition, uranium will get deposited. Second alteration will be hematization and chloridization along fault and fracture zones. Genesis will be oxidized uranium-rich fluids from overlying sediments react with reducing fluids from basement rocks near unconformities, causing uranium to precipitate along faults and fracture zones. This is the genesis, right? Okay, so the sandstone type deposits or Domiasiat Meghalaya. Remember Domiasiat Meghalaya, we have sandstone type deposits. So remember to name it as uranium bearing Domiasiat Meghalaya. Always call it like that. Uranium bearing Domiasiat Meghalaya. So host rock is Mahadek sandstone. It is in Assam basin. Cretaceous interbred with shale and coal. Okay, Mahadek sandstone. So uranium minerals, pitch blende, uraninite absorbed onto organic matter. Okay, so organic matter bearing pitch blende and uraninite. So porous sandstones units with reducing agents, organic matter. Redox from organic matter always gets deposited in a reducing environment. Okay, for oil generation. So redox from front of formation, oxidized overlying layers and reducing lower zones. So this is a redox reaction. Don't have much importance in your answers. Okay. So genesis, oxidizing groundwaters carries uranium through porous sandstones and deposit it at redox fronts where it meets reducing agents like organic matter or sulfides, forming stratiform ore bodies. Okay. So oxygen, uranium bearing fluids or groundwater, here we have this. Then we have oxygenated sandstones. This is oxygen sandstones, reducing sandstones, unaltered sandstones. So this is just a diagram to show how this uranium deposits happen. So we have reducing sandstones here, and we have oxygenated sandstones here, and ore bodies form at this redox front phase. Redox front is the junction between reducing and oxygenation zones. Okay, redox front. So ore bodies are red colored marked. Okay. Now we have strata bound type or Kadapa Basin, Andhra Pradesh. So host rock is Vempalle, Dolostone and Quartzite, Vempalle Quartzite, Karappa supergroup, if you remember our Indian stratigraphy class. So uranium minerals are autunite, torbanite, and uranophane. So I've discussed Indian stratigraphy. If you are following our lectures from the start, you will see that mostly completed Indian stratigraphy in the first topic to be completed, because every other economic geology, igneous geology, sedimentary geology, all those things are at the end it will be connected to Indian stratigraphy, because we have to know where these types of rocks are found. That is why I covered the Indian stratigraphy at the first as the first topic to be over with, and then I started different mineralogical, different crystallography, and then petrology and other things. So now we are in economic geology. So we have Vempalle, Dolstone, and Quartzite, Autinite, Torbanite, Uranophone, restricted to specific sedimentary horizons, that is bedded nature. Silicification and minor chloritization will be there. Genesis is uranium was syngenetically deposited during sedimentation and later remobilized by fluids concentrating along favorable stratigraphic horizons like dolostone under low grade metamorphic or diagenetic condition. Okay, so this is the strata bound Kadapa basin. Then we have fracture control type in Aravali region. So we have quartz, phyllite, and granite gneiss. Again, uranite pitch blend. So just remember, uranite pitch blends are the most common that are found in India. And then secondary uranium oxide. So don't have to remember it. Just write uranium pitch blend everywhere. But just remember that in strata bound Kadapa we have autinite and torbanite here. No uranite and pitch blend. Others you will mostly find see pitch blend here, uranite here, and pitch blend uranite, pitch blend here, but not uranite. But yeah, so more or less like that. Pitch blend and uranite are the common minerals. So controls are vertical to subvertical fractures and zones or joints, alteration hematites and clay for alteration along fractures. Genesis uranium bearing fluids ascend through fractures and joints, depositing uranium minerals when encountering reactive walls, rocks, or changes in temperature, pressure, or redox conditions. Okay, so note 4 and 5th types are not so important. So 4 and 5th are not so important, but 1 to 3 are very important. Okay, so vein type deposits, unconfirmated rated deposits in Andhra Pradesh, and sandstone type deposits of Domiasiat, Meghalaya, uranium bearing Domiasiat, Meghalaya. Okay, these three are very important. So to summarize everything, how these are formed. So we need an oxidizing uranium liquid, uranium bearing liquid. It needs to find a permeable zone. So it can be a fracture, it can be joint, it can be a fault zone. Okay, it can also be an unconformity, and that also it needs a reducing environment during its deposit. So at reducing environment at a particular pressure and temperature, it will, or particular pressure and temperature, and also a redox condition, and then it will deposit those minerals as pitch blende, or it can be mostly uraninite and pitch blende. Okay, so this is the summary of uranium deposits. So now we'll talk about Indian deposits of uranium. So we have Jadugoda and Bhatin. Okay, so uranium deposits of Jadugoda and Bhatin. So we have location as East Singhbhum district, Jharkhand. Host rocks are metamorphosed Archean granitic rocks. Okay, Archean rocks are there. Geological setting located in the shear zones within the Singhbhum Craton. Okay, stratigraphy is Singhbhum Craton, obviously. So process of formation formed from hydrothermal fluids that migrated and transported uranium in reducing environment. So same thing. Okay, just have to remember this process, and you can write it in any Indian deposits how this take place. So hydrothermal fluids is important. Precipitation is important. Uranium in a reducing environment is important. Also, you can just add maybe in fractures and joints, because all types of these basins and formations will definitely have fractures and joints or any kind of permeable zones, until and unless there is an unconformity. Then you have to specify the unconformity. Otherwise, there you can just specify fractures and joints or permeable zones in reducing environment. Okay. So mineralization will be predominantly uraninite, UO2 with minor coffinite, USiO4. Structure is mineralization occurs in quartz veins, again veins deposits, within fractures in the Archean granite. So mining operated by Uranium Corporation of India Limited (UCIL) using underground mining methods. So we'll talk about underground mining methods in the mining part of uh, your topic. Okay, mining topic, mining subject. Then we have Rohil. Rohil is in Rajasthan, Pali district. So host rock is metasedimentary rocks located in the Proterozoic Aravalli supergroup. So this was in Archean, East Singhbum, okay, and this is in Proterozoic. This is Archean granitic rocks and Proterozoic metasedimentary rocks. So uranium mineralization associated with sandstone hosted deposits. So this is mostly sandstone hosted. Process of formation formed from hydrothermal fluids precipitating uranium in sedimentary rock formations. Mineralization includes uraninite and other uranium minerals. Structure is deposits. Deposits occur in sedimentary layers and faults. The sedimentary layers are there and faults are there. Mining will be exploration stage with planned development by Indian government agencies. So mostly is in exploration stage. Okay. This is Rohil. Jadugada and Bhatin is very important. Okay. Then Kadapa Basin, that is in Tummalepalle deposits, located in Kadapa district, Andhra Pradesh. Archean granite rocks of the Kadapa Basin, unconformity rocks. Okay, so remember in Tummalepalle we have unconformity rocks. This is very important. Geological setting is unconformity rocks, located within the Kadapa supergroup. Okay, and process of formation is formed through hydrothermal process with uranium precipitating in unconformities. Mineralization is this deposit primarily contains uranium minerals such as coffinite and uraninite UO2. Structure will be mineralization occurs in unconformities. Mining currently operated by again UCIL with ongoing exploration and development activities going on in the Kadapa basin. Then Mahadek Formation in Meghalaya, West Khasi Hill District. So Phanerozoic sedimentary rocks, mainly shales and sandstones of Mahadek Formation, part of the Shillong Plateau region situated in the Mahadek Basin. Okay, so uranium mineralization is linked to hydrothermal process that lead to the deposition of uranium in sedimentary sequences. Contains uranium mineralization such as coffinite and pitchblende. Deposits are located within sedimentary layers and often associated with structural features like folds and faults will be there. So folds are very common in Assam basin. So therefore we get to have folds and faults also. So exploration and potential developments are underway by various geological surveys and research institutions. Okay. So we have this Domiasiat Wakhin Mahadeks sandstone type. Shillong. Vein type Jadugora Narva Pahar. Singhbum shear zone in Jadugora Narva Pahar, that is near Jharkhand, Bengal border. Then we have Lambapur, Chitrial in Kadapa basin. Okay. Tumalapalle is Kadapa basin, strata bound. Gogi, Bhima basin, vein type. And here Rohil, North Delhi fold belt, vein type. Fine. So these are the major uranium deposits of India. Okay, now we'll talk about exploration and mining of uranium in India. So India is one of the largest producers of uranium in the world, with Uranium Corporation Limited or UCIL uh, operates mining in Jharkhand, Rajasthan, and Andhra Pradesh. So uranium mining in India is largely underground. So underground mining is the most common term used uh, due to depth of the deposits. So we have uranium deposits mostly at certain depths where we cannot do open cast mining. So we'll talk about how at what depths we can limit, if we can limit the our ore of interest at a certain depth, then on what basis we will go for open cast mining, and on what basis we will go for underground mining. So we'll talk about those things. So these are very interesting things. So okay, so primary process for uranium extraction is through alkaline leaching, where sodium carbonate and sodium bicarbonate are used to extract uranium from ore. Okay, so we use this sodium carbonate and sodium bicarbonate to extract the uranium from ore.